All right, so here comes another instructional video. I'm going to be going over exactly what's going to be on the test that is set for Wednesday, but I may put it to Thursday to give the kids and y'all some extra time to work on this. So what this is I've set up the first problem. What they're going to be doing is they're going to have to do the same division problems 2 times. Once like this, which is the base 10 model, the one we did before, that's all in unit form, right? Then they're going to have to do the exact same division problem in the box method. That is the new one that we did. And they will have to write, I don't know, maybe 3 sentences or 4 sentences to comparing how the 2 methods are the same and 2 comparing how the 2 methods are different. And there will likely be 2 problems like that, so they'll have 4 sentences with one, 4 with the other. They cannot repeat any of the sentences. They have to be different. And it will culminate in checking both problems with multiplication using the jellyfish array. So, we're going to get started here. Now, y'all are going to need to, I'm going to be pausing this video for at strategic times so that you can do it, and then I'll wait, and then I'll do it, and we can move in steps like that and hopefully do it fairly quickly. So I've almost completed setting up the problem, which is, of course, 9,798 divided by 5. Huge number. But size does not matter here. It's all basically multiplication, division, adding and subtracting of single-digit numbers, just 0 through 9, not even 10, really. All right. This is 9,000, and this time I've drawn the thousands. Last time I didn't, and I think it confused some people. So I've got 1, 2, 3, 4, 5, 6 thousands. I'm going to draw 2 more so that those of you who wish to draw the cubes know how to draw them. You can watch this. So basically you're going to draw 2 squares. So I'll do it a little bit big. Here's the first square. Then starting from about the middle, you draw another square. Doesn't have to be perfect. And connect all of the vertices. There's your cube. The square or the squares, the square or the cube, or the cube or the square, or something like that. So here's another one. Let's try and make this more cubist. Where is mine? Here it is. I'd like to have Picasso be proud of me for making at least one cube slightly cubesque. Oh, ba-dum, ba-dum, ba-dum. So we have 1, 2, 3, 4, 5, 6, 7. Is that 8? 3, 6, 7, 8. We need one more. I'll do it right here. There's 9,000, 7 hundreds, 3, 6, 7, 9 tens, 8 ones. So I'm going to pause the video, and then you're going to set up yours and make sure and put your divisor squares, which I didn't do. 5 of them. One, 2, 3, 4. Und. Una más. We have 5. Now, it's your turn. When I say go, you pause the video and set up yours just like mine. Ready? Go. Well, you should be done now. And over here on this other whiteboard over here, I'm going to endeavor to actually put some sentences here that you can actually use on the test. So we're going to write some sentences as we're going. We're going to start this now. Let's move this over here so I can just do that. Well, when I'm looking at this and I think about the box method, the first thing that comes to mind is I don't have to draw the unit pieces, the unit measurements in the box method. You just write the digits, right? So it's easier and faster. So I'd say, let's see, we'll go box method is easier because you can write the digits instead of drawing them. And I know y'all can see my writing and everything, but you can pause the video here and actually write the sentence. It is, the box method is easier because you don't have to draw the digits. You don't have to draw the digits. You can write them. Maybe I should read it, what I wrote. Box method is easier because you can write the digits with the box method instead of drawing them with the base 10 method. This is going to get kind of crazy. So, again, box method is easier because you can write the digits rather than draw them. Write that down. Go. Okay, so there's one sentence that you can use, and I'll try as we move on to make it a little easier for you to see. So, let's go back now to the base 10. I hope you have your step-by-step division guides that are supposed to be of the box method, yes, but as I said today, the steps are identical. There is no change. They're exactly the same. Oh, is that a similarity? We have a difference here. Something that's same about them is the steps for both methods are exactly the same. There is no difference between the steps. So now let's get to bing. First step should be setting it up and then partition. So we start with the greatest place value, which is the thousands, and we have to partition sets of 1, 2, 3, 4, 5, right? Well, there are 3 there, and if I draw a lasso around those 3 and 2 more, there's one set of 5, 1, 2, 3, 4, 5, but then we have 4, so we've only got one set of 5. So that means every one of the divisor squares gets 1,000 because there's one set. Just like when we had the cheap column here, would have been 5, 10, 15, 20, 24, right? We'd have gone to 5 and then down to 10, and that would have been too many because we needed how many sets of 5 in 9? So everyone gets 1,000. I'm just going to write the digits in here. This is just too messy to have to draw them. Nah. So 1,000, 1,000, 1,000, 1,000, and 1,000. There we go. These are gone. Now, we need to decompose these, right? That's the next step. So, I'm going to pause, and I want you to decompose all 4 of these thousands into hundreds. Remember, this is base 10. When you decompose, you break up into sets of 10. When you compose, you take sets of 10 and glue them together to make the next place value higher, right? So you're going to decompose these thousands into hundreds. Over here, ready, and go. Good job. So, now, what you should have done was said, okay, well, I'm going to take this guy, and this is what I do, because this method is too crazy. I'm not going to draw 10, 20, 30, 40 squares. It's crazy. I'm going to draw a square, and put a 5 in it, and another one, and put a 5 in it, and that's 10. Then that got rid of that one. Then this one, I'm going to do the same thing. 5, 5, and that's gone. So we have 10, 20, 10, 20, right? And then we have 20 more. So I'm going to go 5, 5, and 5, 5. So 10, 20, 30, 40, 10, 20, 30, 40. They're all gone, right? We are done with the thousands. We're doing the hundreds now. We have to make sure we've got it right. We started with 7 hundreds, right? 1, 2, 3, 4, 5, 6, 7. We decomposed 4 thousands into 40 hundreds. 5, 10, 15, 20 hundreds plus 5, 10, 15, 20 hundreds is 40 hundreds. Plus the 7, we have 47 hundreds. And I just don't know my multiplication tables well enough to figure this one out. It's 47. See, if I had that 5, 10, 15, 20, 25, 30, I just take my finger down until I got as close to 47 as I could without going over it. And that would be my answer. And, oh, well, I can skip count by 5s, right? I can skip count. 5, 10, 15, 20. There are 4 sets, right? 25, 30, 35, 40, 45. That's 9. Am I right? 9. There are 9 sets in here. Let's check it. Let's see. We want sets of 5. Oh. That's easy. We've got, let me do a different color. We've got 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 9, 2 left over. What is 9 times 5? 45? 46? 47. We just checked using multiplication. Because each one of these is a mini multiplication problem, right? They are, every time you do in the box method, when you put an item up above, that is a partial quotient, like a partial product with the jellyfish array. So, to check this, you do the same thing you would with up here. You got to multiply. If you have a remainder, add that, and it should get you to this. All right, so we have 2 left over. We have 9 of these. I'm not going to draw 900s. So I'm just going to write 900, 900, 900, 900, 900, and all of those are gone, and now you've got the 2 hundreds left that need to be decomposed into tens, which you are going to do. You're going to decompose them, then you're going to partition them, and you will put however many tens you're supposed to get down there. That's what you're going to do. Decompose, partition, share. Right? Ready, and go. Good, you're back. Did you go to the bathroom? If you had to go to the bathroom, that was a good time. If you haven't gone, don't you pause this. Don't you pause this to go to the bathroom. You're going to stay until I tell you can go to the bathroom. I see you reaching for that pause button. Gita. So, what you should have done was, you got 10, 20, right? So I'm just going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes. Gone. Gone. We need to check. We had 8 tens. We added 20. There should be 28. 5, 10, 15, 20, 25, 26, 27, 28. There's 29. 5. 1, 2, 3, 4, 5, 6, 7, 8. Oh, see, that's why you've got to check. We have 1 too many. Had that stayed, you'd have got 0 on this problem. So now, 5, 10, 15, 20, 25, 26, 27, 28, we are golden. We're good to go. Now we need to partition sets of 5. Oh, how hard for this one. So that's 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5, with 3 remaining. So you should have gone and here and put 50, 50, 50, 50, 50. I hope you've noticed that what you put into here when we do the box method will be what you put on top of the boxes without the zeros, right? You're going to say, well, we got 9,000. We got to see how many sets of 5 are in 9,000. There is one set of 5, which is 1,000. And you're going to put a 1 up top without the zeros. Then you're going to put a 9 up top without the zeros, and then a 5 up top without the zeros. And the next thing you need to do is figure out how many 1s are going to go in here or on top, if there is any remainder, and if there is a remainder, how you're going to choose to express it up there. So you're going to finish this problem, decompose, partition, share. If there's a remainder, do what you think you should do with that remainder. Got it? Get it? Got it? Good. Go. My goodness, that took you a long time. I'm getting old. I can't sit up here forever waiting for y'all to get done. Wow. All you got to do is decompose from the 10s. Okay. Let's see. So, that's 30 of them, right? 10, 20, 30. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10, 20, 30. 8. 38. We had 8. Decompose. We did the 30. 38. We're good to go. So now we need to partition sets of 5. So I'm going to say, well, there's 2. And 2 more. And 2 more. And here is 1. So we have 1, 2, 3, 4, 5, 6, 7 sets of 5. That's 35, 36, 37, 38. We are good. 38. So 7 each. It's a 7. This is the time where you will not be lying when you do the box, because the 1s are always language of truth, right? And we have 3 left over. So, in that, I gave you no context for this. I did not say what you were sharing. It's just the raw algorithm, the abstract algorithm, no concrete context like babies or puppies or anything we're sharing. So you don't have 3 puppies or babies left here. You've got what we say in our heads. We say this is gold bullion, so you better share all of that, right? So that means if we have 3, we're going to have to take each one of those and cut them into 5 equal-sized pieces, right? So that's going to mean each person, each group here will get 3 out of 5. So it's 3 fifths, 3 fifths, 3 fifths, 3 fifths, and 3 fifths, right? You got each one of these into 3 equal-sized pieces, or 5 equal-sized pieces. Each one gets a piece of the 5, 1/5, then each one gets another 5th. 1/5 out of here goes to each one. Another 5th out of here goes to each one. And a 3rd 5th out of here goes to each one, meaning 3 fifths, 3 fifths, 3 fifths, 3 fifths, 3 fifths. The answer should be now, 1,957 and 3 fifths. You may choose to put remainder 3 if you choose. That's fine for this one. But as we move on in the year, I'm never going to accept a fraction when there is no context. There's no context. Okay? I'm never going to accept a fraction. If there is context, you have to choose whether or not it is going to be a fraction. If we're sharing cookies with our friends, we get a fraction. Gold, we get a fraction. Mercedes-Benz, no fraction. Puppies or babies, no fraction. Right? All right. So, this is the end of step 1. If you tune back in a moment, you'll be able to watch part 2, where we do all of this with the box method. So, now you may turn off when I'm done. When I'm done, go to the bathroom, wash your hands, come back, and do part 2. Don't be late. You got 3 minutes. Let's see.